Let us understand binomial distribution. Binomial distribution can be thought of as simply the probability of success or failure. It is derived by Jacob Bernoulli and also called as Bernoulli's distribution. Consider a survey repeated finite number of times n having only two possible outcomes, success or failure. Tossing of a coin giving head or tail, either head or tail can be success, the other one will be the failure. Result of test, that can be pass or fail, or a yes no question, all these fall under binomial distributions. Let us now denote the probability of success by P, which is constant for each trial. Then the probability of failure, which is denoted by Q, is 1 minus P, that is total probability minus probability of success. The trials in Bernoulli distribution are statistically independent of each other, which means none of the trials have an effect on the probability of the next trial. The probability of obtaining X success in n trials is given by binomial distribution. Consider an example of rolling a die to get a 1 on the face. Roll it 20 times and we get binomial distribution with n equal to 20. Success of getting 1 on the face gives probability P, that is of success, equal to 1 by 6, getting 1 out of 6. For the same question, if the outcome is to be or the success is to be die landing on an even number, then n will remain 20, but P, that is probability of success, will be 3 by 6, that is 3 even numbers out of 6. So answer of P is 1 by 2. Let us proceed further with the first assumption of getting 1 on the face by rolling a die. To explain binomial distribution, suppose rolling die gives series of success and failure. That is, success is getting 1 on the face and failure is getting any other number. Then probability of X success in that order is P of X equal to Q into Q. So this Q is probability of failure corresponding to this first result where our trial has failed. So here we are getting failure. So here we have probability of failure. Here also F, that is failure. So Q, again probability of failure. Here we are getting 1 on the face and therefore this is our success, and therefore here probability of success P. For this failure, this probability of failure Q. So here we will get Q, again here Q, here we will get P because again 1, so success. Here again Q, P, P and so on. So when we have X success, this P will appear X times and Q will appear n minus X times, where n is the number of trials minus X is the success. So n minus X will be the failures. So probability of failure will appear n minus X times and P will appear X times, and it will be written as P to the power X, Q to the power n minus X. But it is not necessary that we will get the same results rolling a die and in the same order also. So then what we will have is different patterns of the results. And when order is not important, these patterns can be described by combinations. So we will have different combinations of P to the power X, Q to the power n minus X, and therefore now this probability will take the form NCX P to the power X, Q to the power n minus X, where this n factorial upon x factorial into n minus x factorial is the formula for NCX. So this is the probability function given by binomial distribution. Let us see some properties. So if x is a random variable obeying binomial distribution, then the probability function of the binomial distribution is given by p of x equal to ncx p to the power x q to the power n minus x. And for this, we can find out mean as n into p, variance as n into p into q, and standard deviation as square root of n into p into q, where n is the number of trials, p is the probability of success, and q is the probability of failure. Consider an example of 1000 coin flips. Now when we flip a coin, either we will get head or a tail. In both the cases, the probability of success, if we assume head to be success, then probability will be 1 by 2. If we assume tail to be success, then also probability will be 1 by 2. So 1000 into 1 by 2, we will get mean as 500. We will get variance as n into p into q. So here if p is 1 by 2, q will be 1 by 2, and therefore we get variance as 250, and positive square root of variance, that is standard deviation, nearly equal to 16. Let us go further with examples. Find the probability of getting exactly 2 heads in 6 tosses of coins. So here we will go with the binomial distribution, and such type of examples are asked in GATE exams. So binomial distribution gives you formula p of x equal to ncx p to the power x q to the power n minus x. What we need to identify from the given problem is this n, x, p, q. So all these 4 elements we need to identify. Now here getting exactly 2 heads is the random variable x in 6 tosses of coin. So our number of trials becomes 6. Now when we toss a coin, the probability we all know it is always equal to 1 by 2, probability of getting head or tail, whatever it may be. Here it is heads, so probability of getting head is 1 by 2. Q will be obviously 1 minus 1 by 2, that is 1 by 2. And we want exactly 2, so substituting the values in the formula and simplifying or calculating, you will get the answer as 15 by 64. Another example, if 10% of the bolts produced by a machine are defective, then find the probability that out of 10 bolts chosen at random, at most 2 bolts will be defective. Again, we go for binomial distribution with the formula ncx p to the power x q to the power n minus x. And now here n is the number of trials. So we are finding out of 10 bolts. So our trials is 10. X is the random variable. X is getting at most 2 bolts to be defective. So here our success is getting a defective bolt. And what is the probability of success p? It is 10% of the bolt are defective, and therefore 10% is our probability of success. So 10% will be 1 by 10. So x at most 2 bolts will be defective. At most means maximum. So it can be less than 2. Less than 2 is 0, 1, and at most 2. So 2 will be also included in that. So this is a discrete type of distribution, and therefore when we are choosing bolts, obviously we are going to get different values, that is 0, 1, 2 can be defective. Then we have seen that number of bolts out of 10 we have to select. So trials is 10. Probability of success is getting defective bolts. So this 10% is 10 by 100. So 1 by 10. Q will be 1 minus 1 by 10. So that is 9 by 10. And now we need to calculate probability for x less or equal to 2. So in that case, for at most 2 bolts, we will write probability less or equal to 2 as P of x equal to 0 plus P of x equal to 1 plus P of x equal to 2. And substituting the values in the formula for x equal to 0, here x equal to 1, here x equal to 2. Our trial n was 10, P was 1 by 10, Q was 9 by 10. Now here x is 0 in this first term. So 10 minus 0 in the second term, x is 1. So here n minus x, that is 10 minus 1. And likewise, calculating, we get the answer as 0.9297. Another example, a box contains 10 screws, 3 of which are defective. 2 screws are drawn at random with replacement. What is the percentage of probability that none of the 2 screws will be defective? Again, here getting defective screws is our success. So using binomial distribution again, so x random variable is getting defective screws, and how many screws we want defective? None. So x is 0. Then the number of screws are drawn at random with replacement. How many are drawn? So these are 2. Out of 2, none should be defective. P is probability of getting defective screws. So out of 10, every 10 we can say 3 are defective. So 3 out of 10 is the probability of success of getting defective screws. Q will be 1 minus 3 by 10, that is 7 by 10. And substituting the values of x, n, p and q, our probability of x equal to 0 comes out to be 0.49. But here what is asked? Percentage of probability, and therefore we convert it to percentage, that is 49%. So this is all about binomial distribution.